wireless USB protocol discussion is flow control. Okay, next we are going to see about flow control. Before that, we have to know what is flow control actually, when we are going to use this concept, everything, right? So flow control is used to prevent buffers from underrun or overrun situation by using negative acknowledgement handshake to throttle the data rate. Getting what is underrun, what is overrun? In 5.4, you might have come across a 5.4 concept, right? In that overrun concept, underrun concept is there. Overrun means suppose in 5.4 10 locations are there. Okay, from the right side we are writing 8 data. After that we are writing 2 more data. Okay, in the meantime we are not fetching any data from that memory. Okay, so right now the 5.4 has been filled, but still that right side wants to write some data. This condition is known as overrun. Okay, and underrun in the sense that just opposite to this overrun. Underrun means what? It is a read side reading some data. Okay, it is keep on reading. It has read all the data from that memory. Now there is no data inside that memory, but still it wants to read some data. In that case, what will happen? That will show underrun condition. So this is all about overrun, underrun. Similarly, in wireless USB also, in the device side we will have so many buffers. Actually we know that endpoints are nothing but buffers, right? So in that, if there is any no if there is enough data, but still host side wants to write some data, so it has to um, inform those information to the hosts, right, through this flow control event. How it will inform these conditions to host means do by using some negative acknowledgement handshake signals. Okay, when negative acknowledgement signal NACT, a transaction is retried when the bus time is available. Are you getting this point? Now the device has filled with full of data, right? So it is telling the host that the last data you have sent to me has not been received, so better you retry again, like that it is telling. Okay, so when after some time, if host is having the data control over the bus, then it will send that data. That is nothing but a retry, right? Again it is sending the same data, because it came to know that the last data is sent to the device not been received properly. The flow control mechanism permits the construction of flexible schedules that accommodate concurrent servicing of a heterogeneous mix of stream pipes. Thus, multiple stream pipes can be serviced at different intervals and with packets of different sizes.
Multiple stream pipe means
We know what is pipe.
pipe is a logical connection between.
That's right. So streams, so many streams will be there. Okay. In a single device, we may have so many functions, right? So each function may have their own endpoints. So each one will have their separate stream. So that is all about the multiple stream pipes. They are trying to say about that thing. But in that, if we are having 2 or more pipes, now control transfers. Now we'll see the control transfer read flow control. Okay. Now look at here what's happening. First, MMC is sending some setup bytes. Okay, setup bytes. After that, device has to send a handshake signal, right? Getting? So host stops polling the endpoint on negative acknowledgement. Now what will happen? Are you getting what's happening here? This is a control transfer. So control transfer, we know that it will start with the setup bytes. Okay, so it is sending setup bytes, but device is already in process, so it is not able to receive that setup bytes. So what it is doing, it is sending negative acknowledgement. So host is not scheduled any transaction for this endpoint. After some time, this device is sending device notification ready. Now the host will send the old data, that retried data here. Getting? So again the data stage is started here, and after that status stage. So yeah, in the first phase, host stops polling endpoint on negative acknowledgement. After that, device is notifying the host that now it's ready, and